Welcome to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. So if you wanted to see this video, you may check it into my playlist. So in my today's video, I'm going to explain to you all one of the question. It is from CSIR NET previous year question paper, which is from paper second. That means multiple answer correct question that we have to verify each and every option very carefully. Now let's get started on today's question. First of all, I'm going to explain to you all the question. We'll see, understand first of all the options, and then we'll go for the detailed understanding of our all solutions, okay, of our options. Now let us start. Question: we have given xn be the arbitrary sequence, okay, of a real number. What we have here, xn is the arbitrary sequence of a real number. So all the sequence which taking the number from all real numbers, okay, and arbitrary sequence you may take anything, okay, and then we have to figure it out which one of the options are correct. Okay, 4 options are given. Option A, it says that series n running from 1 to infinity, modulus of xn raised to p smaller than infinity for some 1 strictly less p strictly less infinity. Second option, n is equal to 1 to infinity, modulus of xn raised to q strictly less infinity for any value of q strictly greater p. Okay. Option B, it says that n is equal to 1 to infinity, modulus of xn raised to p strictly less infinity for some 1 strictly less p strictly less infinity, and this implies series n running from 1 to infinity xn raised to q smaller than infinity for any values of 1 lesser equal q strictly less p. Okay, and option C and D, it says that 1 strictly less p strictly less infinity, then the series of sequence xn such that n is equal to 1 to infinity xn raised to p smaller than infinity, but n is equal to 1 to infinity xn raised to q smaller than infinity. Okay, so we have given C and D option, so we have to figure it out which one of the option is correct from A, B, C, D. Okay, now let us see. Let's start the solution. First of all, we understand the solution, then we'll go for the detailed understanding of our options. Okay, first option, it says that xn raised to p smaller than infinity for some 1 strictly less p strictly less infinity, and n running from 1 to infinity xn raised to q strictly less infinity. Okay, and for any q strictly less p. Okay, and now here we can see sequence. We have to check whether, okay, so here whether so first sequence, it is smaller than xn raised to p smaller than infinity, but xn raised to q smaller, which is equal to infinity, and xn raised to p smaller than infinity, and xn raised to q smaller than infinity. Okay, the meaning for any sequence is a finite. That means if any sequence is a finite for any particular point, then we say that the sequence is convergent. Okay, the sequence is convergent. For if the sequence is finite, finite means it is having some finite fixed value. Okay, not infinity means it is having finite some fixed value. So it it goes to the sequence, it is also convergent. Okay, which is smaller than infinity means finite and having the finite values. Okay, it is obvious result that finite convergent sequence can be matches to finite convergent sequence. Okay, whether it is power p or q, and p and q is having a relation 1p infinity, and q is bigger than p. Okay, and option C, it is a similar like option A, so that's why I taken A and C together over here. So it is given 1 strictly less p strictly less q strictly less infinity. So there is a sequence xn such that n is equal to 1 to infinity xn raised to p strictly less infinity, but n is equal to 1 to infinity xn to the power q is equal to infinity. Okay, so here option C, we can see that xn raised to p, which is a finite and convergent. Okay, if it is finite, that means converges to some convergent point. Okay, so first series is convergent raised to p, but here it says that if we take the relation p strictly less q, xn raised to q is a divergent. Okay, it is infinity means that it lands to infinite value, that cannot give us a finite or zero value. Okay, so that's why this series is divergent. If finite series we take on here convergent, can it goes to the infinite? Okay, never possible. But let us verify with some counter part example. Okay, so we have taken a series xn raised to p is a convergent for one strictly less infinity given in our question. Okay, that means it is a convergent, that means it converges to some particular point. So I consider limit n tends to infinity xn raised to p, I consider as a it converges to 0. If it is converges to 0, then limit n tends to infinity xn raised to q need to also go to 0. Okay, why it need to go to 0? Because p and q, it is finite, smaller than 1 and bigger than 1 and smaller than infinity. That means both are the finite. That means if it is goes to 0, that means it also goes to 0. Okay, as q is bigger than p. But it says that it goes to infinity, q goes to power q goes to infinity, but it never possible. Okay, this never possible. I hope you all have understood. And by comparison test, if we know that what is mean by comparison test, if we have sequence xn lesser equal yn, okay, then comparison test, it says that, let me explain first of all comparison test, then we'll go for this option. Okay, comparison test, it says that if yn it is a convergent, then we say that xn is convergent. Okay, if we say that yn is convergent, then xn is convergent. If xn is a divergent, this implies yn is a divergent. Okay, this is the condition for a conversion test for comparison. Okay, so comparison conversion test, so it is very easy. Okay, nothing is difficult over there. So if you read this concept from the real analysis, you will solve this question just an observations only. Okay, nothing is difficult over here. So here we can see if xn raised to p goes to 0, then xn raised to q need to go to 0. Okay, but it says that it goes to infinity, never possible. But if we compare this, if xn is convergent, then xn raised to q need to be convergent, these both need to be convergent, but one given divergent, so our option C is wrong. And as we have condition, if p is divergent, then q is divergent. Okay, but here we can see that p is convergent, okay. So xn raised to p is convergent, then xn raised to q need to be a convergent. Okay, because we have here p and q between 1 and infinity. Okay, if p is convergent, then q is convergent. So here we can see that xn raised to p is finite and convergent. It lands to xn raised to q finite and convergent. Okay, by comparison test, we say that option A correct and C wrong. Okay, very easy options. Nothing is there and no need to explain anymore for such easy questions. We do not have to take counter also, that you can answer this question by observations if you know the comparison test. Okay, now let's go for the next option. So we got the A correct, C wrong, because these are the related options. A which associated with the C, they are the related option. Now let's verify option B and D. Okay, so here in our option B and D, we have given series is convergent for some 1p infinity and 1q strictly less p, which lands to xn raised to q strictly less infinity. So convergent series goes to convergent, but condition for p and q given, p is smaller than infinity but bigger than 1, and here 1 is smaller than q and q is bigger smaller than p. Okay, so p is bigger over here, the value for p which goes to big and big. Okay, but the value for q which is smaller than p. Okay, and next option D, it says that 1 strictly less q strictly less p strictly less infinity, there is a real sequence xn such that xn raised to p strictly less infinity, but xn is equal to 1 to 1 infinity, xn raised to q is equal to infinity. Okay, let us see, we'll take some counter. Okay, if I take xn is equal to n to the power 1 by n, okay, n to the power 1 by 2, and if I consider p is a 3, q is a 2. Okay, so what we have condition, p is need to be a bigger, q need to smaller, bigger than 1. So if q is a bigger than 1, so I consider q is a 2 which is smaller than p is a 3. Okay, by using this condition I consider this one, and the sequence xn I consider real sequence, it is a finite and convergent. Okay, we can see that 1 upon n raised to 1 by n, as n goes to infinity this series goes to 0, that means it is convergent Okay, so if this is a convergent, then modulus of x n raised to p. Okay, so modulus of x n raised to p, find out the value, what we will get it here. So modulus of x n raised to p means series of 1 upon x n raised to 1 3 by 1 by 2 raised to p is a 3. Okay, x n raised to p, that means n raised to 1 by 2 raised to 3, that means it is a 3 by 2. Okay, and by mod p test, if p is bigger than 1, then we say that series convergent. Okay, p is bigger than 1, series convergent, and p is smaller than 1, divergent. Okay, okay, 1 upon n raised to p, if we have series 1 upon n raised to p and p bigger than 1, then say that series convergent, and p smaller than, we say that series divergent. Okay, by mod p test we write n to the power 3 by 2, 1 upon n to the power 3 by 2, which is a convergent. Okay, I hope you all have understood how can we say this series is a convergent. Okay, by using mod p test. Okay, if p bigger than 1, convergent, p smaller than 1, divergent. Okay, now similar to do it for xn raised to q. Okay, so xn 1 upon n raised to 1 by 2 raised to 2, that means 1 upon n, it remain only. Now here we can see that the power which is here 1. Okay, so power which is here 1, that means p lesser equal to 1 here. Okay, so if n p which is equal to 1, which is 1 or smaller than 1, okay, then series is divergent. Okay, that means this convergent series can go to divergent. Okay, but convergent series cannot go to the convergent over here. Okay, with for this condition, for these conditions. Okay, so it says that option B is wrong and option D is right. Okay, so for your better understanding, you may check all my solution with options. Okay, so here is question. After that, option A is correct, option C is wrong. Their explanation over here. Okay, it is explanation. Option B and option D. Option B is wrong, option D is correct by using modulo p test. Okay, so this one is everything for our today's lecture. I hope you all have understood my today's lecture. Nothing is difficult over here. Okay, so even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.